Hello friends, this is Durga again from ITversity. So as part of this topic, we'll see details about how to declare variables in Scala and the concepts behind it. We will also look at data types. To explore Scala, you should primarily use your laptop or desktop, and the demo will be done using REPL itself. And as I have mentioned as part of the last topic, use REPL, you have to set up Scala. And if you directly jump onto this, please make sure you go to this Scala REPL or CLI and you set up the environment before you proceed further with this uh, topic or video. Okay, so first we will see how to declare the variables, and for that we have to launch REPL. Okay, you can say sh clear to clear the screen. :sh will actually issue the shell commands. Okay, it is not clearing. Let me see if there is any clear command here. Okay, let me quit again and then run clear and then launch it. Okay, so when it comes to declaring variables in Scala, you don't need to define the data types. Okay, with Java you have to say string if it is a string type. You have to say either int or integer if you want to use primitive types or classes, but you have to define data type. Whereas in Scala you don't need to define data type, but you have to tell whether the variable is mutable or immutable. That's where this val or var concept comes into picture. Val means the variable is immutable and var means the variable is mutable. Okay, so it's val means it's like final, static final variable or final variable where you cannot change the value of it anytime. If you are familiar with Java, you have to define the variables as final, and there is no default when it comes to Scala. You have to tell whether the variable is mutable or immutable. In case of Java, by default the variables are mutable, and if you want to make them immutable, you have to use final keyword before defining the data type. Okay, so when it comes to Scala, you have to tell whether it is mutable or immutable. If it is mutable, you have to say val, and let's say you define the variable by initializing. Initializing is mandatory. You have to initialize. For example, you cannot just say var I. You have to initialize it to some value. Initialization is mandatory. So in case of this one, I am initializing with 0, and as 0 is of type integer, it automatically inferred I to be type of integer. So it is called as type inference or implicit data types, uh, um, and I is now immutable. So if I want to assign a different value to I, it will not let us. It is saying you are trying to reassign to a value which is not valid. But if you again say val, and if you say I equal to 1, which means it will destroy the earlier variable with name I, and it will recreate a new variable. It is a valid statement. You are creating a new immutable variable, and as part of the scope of the program, uh, you cannot override that value. Okay, because we are developing in interactive mode, it let us to create variables like this. Okay, if you try to run the program, and if you, as part of the program, if you declare I twice like this, it will not work. For example, you can use colon paste, which will get you to multi-line mode or paste mode. Until control D, you can give as many instructions as you want, and it will compile the entire code as one unit, and it will try to execute. So now if I say val I equal to 0, and val I equal to 1 and control D, it complies. It is already defined, and you are trying to use the same name for the variable. Okay, so don't get confused that it will let you to create a new variable within the same program. Because we are using REPL in the interactive mode, each line of code here is a different program altogether. Okay, if you want to write multiple lines of code, you have to be in paste mode. Okay, and now if you want to create a mutable variable, you just have to say var and I equal to 0, and this one you can change it. Now I is 1. At the same time, you cannot change it to a inconsistent data type. It will not work. It will complain type mismatch. Okay, so um, the variables are statically typed, which means once the data type is defined or inherited or inferred, you cannot assign a variable, so a value of different data type to that variable. Okay, so this is how the declaration of variables work. If you want to explicitly define the data types, you just have to say val or var is mandatory. Val means immutable and var means mutable, and then colon, and then you have to give the data type. Okay, if you see the output, you got the same output here as well as here when I declare variable I earlier. Even though I did not specify the data type, it inferred um, based upon the value we are trying to assign. So what will happen is whenever you declare val, internally Scala will generate code similar to uh, final variables uh, at the compile time, and then it will generate bytecode based on that. So if you are familiar with Java, whatever actions it will take when you declare a variable final, the same type of actions will take when you declare variable with val, and based upon the value you assign, it will generate the necessary code to declare the variables, so that the bytecode generated is in line uh, with the semantics of the JVM bytecode. Okay, so this is about declaring variables. There is no, and one more important aspect when it comes to Scala as a programming language is there is no distinction such as primitive types and classes for primitive types. If you are familiar with Java, you can say int I equal to 0, which means I is of type primitive integer. Also, you can say integer I equal to new integer. In this case, I is a object of type integer. You can declare in both the ways. The advantage of using this one is there are functions that are available as part of this class, or APIs that are available as part of this class to manipulate integer type with more extensive functionality. Whereas with primitive types, you don't have those functions available on uh, primitives. The advantage of primitives are performance wise, as it does not create objects. It is much better compared to the class objects or class variables. But when it comes to Scala, even though we could not specify uh, as primitives or classes, as primitives we have to use only classes such as int, float, etc. Still internally, if the variable has to be treated as primitive, depending upon the action you are trying to take, it will act as primitive only internally as part of the compilation and running. If it has to act as object of a class, the Scala compiler will take care of that. You don't need to worry about it. The complexity is hidden for you. There is no two ways to create the same variable uh, or similar variable like in Java. There is only one way, and the complexity is hidden to you. So this behavior of um, running as primitives uh, versus running as class objects as and when it is required is called as value classes in terms of Scala. So for all the primitive types, um, there are only classes, and it runs as primitives as and when it is required to run as primitives, and it run as class objects as and when it is required to run as class objects. And this behavior, the classes which exhibit this behavior, is called as value classes. Okay, and here are the value classes which are available for our primitives. So byte, byte can store the value from minus 2 to the power of 7 to 2 to the power of 7 minus 1. Short, minus 2 to the power of 15 to 2 to the power of 15 minus 1, which is I think 32,768, minus 32,768 to 32,767, or 32,760, yeah, approximately that value. For integer, it is minus 2 to the power of 31 to 2 to the power of 31. For long, it is minus 2 to the power of 63 to 2 to the power of 63 minus 1. Char is to primarily store unsigned Unicode characters, and string a sequence of characters, float, double, boolean. These are the value classes which are available for typical primitives. So let us perform a task here. Okay, so create value a, that is an integer value 42. So you just have to say val a equal to 42. You can also define variable like this. And if you want to create it as a long, you just have to say val b long. Again, this is not mandatory to define it as long. You just have to say, then it will become long. If you want to create a float variable, you just have to say val c float. Okay, so by default, if you do not specify here, it is considered to be double. To make it float, you have to say f, then it will become float. Okay, and uh, and now uh, the task is to create variable d, that is a double value as multiplication of a, b and c. So here I can say val d, and let us first just multiply directly a, b into c and see what is the data type. It is actually of type float. If you want to convert it into double, let us see by just declaring it as double what will happen. It will automatically convert, because uh, double is more generic than float. Um, by default, if you specify double, it will be upgraded to double. Okay, and then create value e, that is a short value 42.0. So val e, and if I just say 42.0, what will happen? It will be treated as double. In this case, we have to explicitly define data type to make it short. Okay, let us see what will happen. It will fail because short does not take the decimals, it only take integer values. Okay, you can say like this. By default, if I say val equal to 42, it would have been integer, because we have defined as short. 42 can be assigned to short, hence it is working. And then val f, that is a byte value, again it will fail if I say 42.0 as byte. Okay, and if I say this, it will work. But if I say, let's say 32,767, it will fail because byte cannot hold that. A short can hold it, but not byte. Okay, so byte is only from minus 2 to the power of 7 to 2 to the power of 7 minus 1, which is 128 or 127. You can assign only up to 127. Okay, if I assign 128, it will fail. Oh, I think it's not 128. Let me see. What is short? Short is from, okay, here I am defining as short, not byte. Sorry. It will fail. But I can say 120. Okay, I think it will be able to store till 60. Okay, again, my bad. It has to be capital B here. It worked. Up to 127 it will work. But if I say 128, it will not work. Okay, because byte only takes up to 2 to the power of 7 minus 1, which is nothing but 127. And then you can also define hexadecimal variables. And in case if you want to define it as hexadecimal, you have to say val h or g equal to 0x42. And you can see the hexadecimal value 42 is nothing but 66. Here it is converted into integer automatically internally. It will always print in decimal format only. It will not print in hexadecimal. Okay, I think if you use print command and if you try to uh, print in hexadecimal format, you can get the hexadecimal value using print command, but the result will always be in decimal format. So this is about declaring variables. The main takeaway is the difference between immutable and mutable, and then the value classes. All the primitives are value classes, wherein you only declare in one manner, and it will act as primitives as and when it is required to act as primitives, and it will act as class objects as and when it is required to act as class objects, and Scala compiler will hide the complexity for the value classes. These two are the most important thing when it comes to declaring variables, and you don't need to explicitly define the data type. It can infer from the value which you are trying to assign, and assignment is mandatory or initialization is mandatory. You have to initialize the variables, otherwise it will not work. That being said, thank you. Bye.